So today we are going to continue studying about chapter 11, section 3, day number 2 or part 2, which is about the standard normal distribution and how to use the standard normal table. Our lesson target for today: I can use a standard normal table to find various probabilities. So in page 759, you can see your standard normal table, and the standard normal distribution is the normal distribution with mean equal to 0 and standard deviation that is equal to 1. The formula below can be used to transfer x values from normal distribution with mean x bar and standard deviation lowercase sigma into z values having a standard normal distribution. So take a look at the formula that you have: z scores equal to value minus average over standard deviation. And as you can see from the bill-shaped curve, you see that is z equal to 0 at the middle when it's around the average, and when we have average plus standard deviation, that is z equal 1, and average minus standard deviation, that is z equal -1, and it goes so on and on. So it goes on and on from the left side and the right side too. So we subtract the mean from the given x value, then we divide by the standard deviation by using this z-score formula. So the z value for the particular x value is called a z-score. Now standard scores. So one use of the normal curve is to explore standard scores. Standard scores are expressed in standard deviation units, making it much easier to compare variables measured in different scales. There are many kinds of standard scores. The most common standard score is the z-scores, which is the z value. And a z-score states the number of standard deviations by which the original score lies above or below the mean of a normal curve. The z-score, the normal curve, is not a single curve, but a family of curves, each of which is determined by its mean and standard deviation. In order to work with a variety of normal curves, we cannot have a table for every possible combination of means and standard deviations. So what we need is a standardized normal curve which can be used for any normally distributed variable. Such a curve is called standard normal curve, which is z-score equal to value minus average, which is x bar, over standard deviation, which is lowercase sigma. So the standard normal curve, or the z-score, or the z distribution, is the distribution of normally distributed standard scores with x bar, which is the mean, equal to 0 and a standard deviation of 1. So a z-score is nothing more than a figure which represents how many standard deviation units a raw score is away from the mean. Let's do an example together for the z-score. So for scores above the mean, the z-score has a positive sign. Example, plus 1.5z. So below the mean, the z-score has a minus sign. Example, negative 0.5z. Calculate z-scores for blood pressure of 140 if the sample mean is 110 and the standard deviation is 10. So it's straightforward to plug in these numbers into our equation. So z-score equal to the value, which is 140, minus the average, which is 110, the mean, over standard deviation, which is 10. And if you do that by using the calculator, you will get 3. Standard normal table. As you can see in this page, the standard normal table. So we are going to calculate some values or some z-scores values by using the standard normal table. So let's do example 3 in page 759. Use the z-score and the standard normal table. So scientists conducted aerial surveys of a seal sanctuary and recorded the number X of seals they observed during each survey. The numbers of seals observed were normally distributed with a mean of 73 seals. So the mean, which is x bar, equal to 73, and the standard deviation, lowercase sigma, is equal to 14.1 seals. Find the probability that most 50 seals were observed during a survey. So step number 1, we need to find z-score corresponding to an x value of 50. So z equal value minus average over standard deviation. So the value is 50 minus average is 73 over standard deviation, which is 14.1. Plug that into your calculator and you will get negative 1.6. Now the z-score or the z-value of negative 1.6, we need to use the table to find the probability that a value is less or equal to 50. So take a look at the table in row number 6 or 7, row number 7, as you can see. And if we look at from the z column at negative 1, so look at negative 1 and column number 7, and you will see that is the probability that at most 50 seals were observed during a survey is about 0.0548. 0.0548, which is our answer. So I hope that helps, and we hit our target, which is using the standard normal table to find various probabilities by looking at the z values or z scores. Thank you. Your assessment is page 11, is page 760, problems 19 to 27. Thank you.